Hello everyone, I am presenting a tutorial of picture detection or image classification using TensorFlow and Keras. TensorFlow is an open source software library for the machine learning. It can be used in different tasks but has a particular focus on training and inference of the deep neural network. Whereas Keras acts as interface for the TensorFlow library. It is an open source software library which provide Python and interface for the artificial neural network. Over here you can see for the particular image classification case study, I've imported all the necessary libraries like NumPy, Pandas, TensorFlow, Keras, and also over here you can see I have imported image data generator and image to array. Image data generator generates batches of the TensorFlow images data with real-time data augmentations. If you don't know about data augmentations, I will make a separate video for that where you can clear your concepts regards the data augmentations. After that, over here you can see I have created two image data generator object, which is one for test data and one for train data, and I have used these image data generator objects to import the train and test data respectively over here. I've used test target size, batch size and class mode for both the cases to import test and train data. I've set the target size to 224, batch size to 10, and class mode to categorical. Then I have performed hyperparameter tuning to get the optimal number of filters and the size of the filters to for the useful for the particular case, which will best fit for the particular case study. For hyperparameter tuning, I have created a user-defined model, which is basically my model. You can see over here I've used two convolution layer. In the first convolution layer I've used range 32 to 228, 32 to 128 for the number of layers, and the filter size 3 by 5, which is size of my filter. I've used activation. I've used the parameter activation and set it to redo for the both convolution layer. Over here you can see, and input shape to 224, 224 and 3 because my pictures are in RGB format. I've add a flatten layer over here. Then I've used a fully connected layer where the dense I've added the dense layer. Also over here you can see I have used mean value as 32 and max value as 128, which is a range for the number of units to get from the hyperparameter tuning, and set my activation to ReLU. And for the output layer I have added the dense layer once again, and unit is 6 as my class. Over here you can see while importing the data I have 6 classes. That is why I have written the 6 in the unit section, and set the activation to softmax as it is a multi-class classification case study. Then I have compiled my model using Adam optimizer and set the learning values from this value to this value, basically 0.01 to point 0.0001. after that over here you can see I've used the random search, which you can see over here I've imported from the Keras tuner for the hyperparameter tuning. Random search basically is a technique where random combinations of hyperparameters are used to find the best solution for the build model. It tries random combinations of range of values. The range values over here you can see I have set these range values for the convolutions layer 32 and 128. Over here you can see I have set the mean value 16 and 64 for the second convolution layer, and also over here you can see I have set the range for 32 and 128, which is for my dense layer unit or number of layers you can say. In the hyperparameter, in the random search, these values are randomly selected and gives me the best hyperparameters for the particular case study, or you can say that after creating a random search object over here, we have used this object to search the best model on the given dataset based on the accuracy or val accuracy. By performing that search function on train data and validating on the test data and set the epochs to 5, and by executing that cell we have got the best model, which gives me the val accuracy of 0.74. Now by executing this cell, we will get the best model, and using the best model we have fitted the train data and set the epochs to 10 and initial epochs to 5. Why initial epochs to 5? Because we have already performed 5 epochs over here. You can see over here. Here it will perform from 5 epochs to 10 epochs, and by executing that cell we can see over here we are getting the accuracy near 99.86%, which is 99%. This code, by performing this code, basically that particular variable is storing the information of class indices, and the result map variable basically storing all the class maps and the corresponding values to it. Like if we print the result map over here, you can see 0 is assigned to the buildings, 1 is assigned to the forest, 2 is assigned to the glaciers, 3 is assigned to the mountain, 4 for sea, and 5 for straight. Now we are importing the particular test image to see how our model is predicting or classifying the images. As you can see, I've used the parameter target size and set it to 224 because over here you can see our model has been trained on the particular target size, which is 224 and 224. Then we convert the image to array. Then we standardize the value, dividing that particular image by 225, or that particular array by 255. Then we expand the dimensions of that particular image, test image. Then we basically predict using our best model and by executing this cell we are getting our predicted result as Glacius.